Have you heard of the phrase, "the dose makes the poison"? This description is fitting for a class of compounds classified as N-nitrosamines. Although we are naturally exposed to low quantities of N-nitrosamines in food items such as cured meat, these compounds increases the likelihood of getting cancer when ingested in sufficient quantities. As a result, they were responsible for several drug recalls after being detected in high concentrations in drugs treating diseases such as hypertension and diabetes. They have also been detected in tobacco products and are key contaminants on the Olin Superfund site, affecting all residents in Wilmington, Massachusetts. Current detection methods rely on highly time-consuming sample pre-concentration and specialized instrumentation, which makes home monitoring extremely impractical as proper training is necessary. This is where my SRP work comes in, as I aim to develop a more accessible detection method for N-nitrosamines that is compatible with smartphone cameras. As a graduate student in the Swagger Lab at MIT, I design and investigate metal-containing materials where the metal centers can bind to the oxygen of N-nitrosamines. My design principle is that whenever an N-nitrosamine molecule interacts with the metal, this causes a change in the material's emission properties. These emission changes may either be the color itself or its intensity, similar to a smart light bulb where its brightness or color can be adjusted. What makes this form of detection accessible to people is that these emission changes can be captured on smartphone cameras, which every one of us carry around daily. So far, my work has shown that several copper-based materials, which emit between green and red, have their emission intensity reduced when exposed to N-nitrosamines. When this technology matures and reaches end users, it will ideally be as simple as anyone using a smartphone application to take photos of a test strip before and after adding a sample potentially containing N-nitrosamines. The application will then analyze the emission changes and estimate the concentration of N-nitrosamines present. I hope that increasing the accessibility of testing will help people without expertise monitor their exposure to N-nitrosamines and raise awareness when excess levels are present.